Lesson 10-3, solving quadratic equations by graphing. We've already been looking at quadratics before. We've graphed a few of them. We've described the key features of them. Here we want to now solve a quadratic equation by graphing. So this means, what does x equal? A quadratic equation can be written in the standard form of ax squared plus bx plus c equaling 0. And just remember, a cannot be 0. Because the graphs of a quadratic functions have 0, 1, or 2 zeros, the corresponding quadratic equations can also have 1, 2, or 0 solutions. Now the solutions are also the roots, the x-intercepts, solutions, but just dealing with where they cross the x-axis. So you can have two real solutions if they cross the x-axis in two places. You can have one solution if the vertex is on the x-axis, and you have no real solution if it never touches the x-axis. So solutions or roots or x-intercepts or zeros can be used to identify the x-intercepts of the graph of the solutions here. When the vertex of the related quadratic function lies on the x-axis, the solution is a double root, which just means that there are two roots of the same number. So an example of this one, here you can see that it crosses in two places, and -2 and 4. So we would say that -2 and 4 are the roots or the solutions or the x-intercept of that function. We're going to practice by graphing this and finding the solutions here. So there are a couple ways of doing this. You can do a pencil paper method, or you could create a table of values on your calculator. If you don't have a calculator right now, I'll show you how to do it without it. We need to find our axis symmetry first. So I'm going to do -b divided by 2a, which is -1. That gives us a +2. And if I plug that into my equation to find my y, so this gives us -4 plus 8 plus 5 should give us 9. Now to graph this, I'm just going to extend this a little bit higher up. So we got 1, 2, 3, 4, 5, 6, 7. This would be 8, and here is 9. I'm going to count by ones. So my vertex is at 2, 9. So 2, 9 would be up here. This does open downward because I have a negative here. I'm just going to choose some points on each side. So if I can do the y-intercept, which is 5. So 0, 5, 1, 2, 3, 4, 5. I can mirror that one. So it's 2 steps to the left, go 2 steps to the right. And then I want to go a little bit further. So if I go to -1, so -1 squared plus 4 times -1 plus 5. So this gives us -1 minus 4 plus 5, which gives us 0. So I have a point at -1, 0. So here, that means I'm 1, 2, 3 steps to the left. I go 3 steps to the right. 1, 2, 3. That goes here. Now I have all my points I need to create my parabola. And my solutions, x would equal -1 and a +5. Next, we'll do the same thing here. Find the x's of symmetry. So I take -7 divided by 2a to give us 7/2 or 3.5. If I plug that in, I get 3.5 squared minus 7 times 3.5 minus 8. I put that in my calculator. I end up getting a -20.25. Now to put that on my calculator or on my coordinate plane, I'm going to count by 4s for my x-axis or my y-axis, and I'm going to count by 2s for my x-axis. So I need to go -3.5, -3 or +3.5. So this is 2, and this is 4 and 6, I would have a point roughly, let me label my y's. So this is 4, 8, 12, 16, 20. So I would have a point roughly here is my vertex. Now my y-intercept is at -8, which would be here. And that means I could go and find out my y, let's try -1. So -1 squared minus 7 times -1 minus 8. So this is 1 plus 7 minus 8. So this is 8 minus 8 equals 0. So I know I have a point at -1. And then on the other side, let's see, we could do, let's try 3. I put 3 in for x. So that'll be 3 squared minus 7 times 3 minus 8. 3 squared is 9. 9 minus 21 is -12. Minus 8 gives us -20, so it can't be 3. Let's try 4. Actually, no, let's try 5. So if I put a 5 here, 5 squared is 25. Minus 35 minus 8 gives us -18. Actually, that wouldn't work there, so let's try 6. Let's see, do 6 squared minus 42 minus 8 gives us a -14, so that doesn't work. Let's go back to, so 25 minus 35 minus 8 gives us -18. So we know we have to go past 6. So let's try 8. So 8 squared is 64, minus 56 is 8, minus 8 gives you 0. 1, 2, 3, so we're coming by 2's. So this was 2, so 1 would be right here, -1 here. 8 would be 2, 4, 6, 8. This would be 8 right here. So now I can draw my parabola. And my solutions would be x equaling -1 and x equaling 8. As I said before, later on I'll show you with the calculator. That would make it a lot easier than doing some guessing and checking. Next one, solve by graphing. I need to make sure everything's to one side and equal to 0. So I'm going to add 16 to both sides. And now I have x squared minus 8x plus 16 equaling 0. Now this one I know is a perfect square trinomial. If I can multiply x minus 4 times x minus 4, -4 times -4 is 16. -4 plus -4 is -8. So if I make those equal to 0, I know my x is going to equal +4. So I have a vertex at +4. So that means my solution is a double root, which would be 4. Now I didn't have to do much more graphing on that because I already know what my x is going to be. Second one, add 4 to both sides. And now I have x squared minus 4x plus 4 equaling 0. Same thing, this is a perfect square trinomial. X times x, so I know subtracting 2 on both sides, make them equal to 0, x is going to equal 2. So this would be my solution for that one. Next, some more of them. So I'm going to subtract 36 on both sides. Here I have -x squared minus 12x minus 36. If I were to factor this one, I could factor out a -1 first, and that would be x squared plus 12x plus 36, and then factor this, which would be x plus 6 times x plus 6. And then I have a -1 on the outside. So if I make each of these equal to 0, that will give us x equaling a -6. So my root would be x equaling a -6. Next ones are example 3. There's no real solutions. That means they don't cross the x-axis. So if we solve this by graphing this on here, if I were to graph it, again, we're going to find the axis of symmetry. So -1 divided by 2 times -2 give us 1 over -4. So if I count this by, let's just say I count by halves, this would be -1/4 right here. If I put -1/4 in, so -2 times -1/4 squared minus -1/4 minus 2. -1/4 squared would be 1/16. -2 divided by 16 give us -0.125 plus 0.25 minus 2. We get an answer of -1.875. So if I put that point in here, so I would have -1.825. So that would be roughly here. And choose a point on each side. I know my y-intercept is at -2. So that is here, and I can mirror that one, which would be over here. Draw my parabola. You can see that it never crosses the x-axis, therefore no solution. Next, try this one. So I have -2 divided by 2 times -2, which will give us 2 on top and -4 on the bottom. That gives us -1/2. Again, I'm going to count by negative halves. So this one would be -1/2. I put -1/2 in, so -2 times -1/2 squared minus 2 times -1/2. This would be -4. So we have -2 times 1/4. And then I need to add 1 to that and then subtract 4. I end up with -3.5. So I put a point at -1/2 and -3.5. That would be roughly here. And then I choose a point. I can choose my y-intercept, which this would be on this side as -4. So 0, -4 would be roughly here. Mirror that one, and I can draw my parabola. It opens downward, never touches the x-axis, so no solution. And another one, which equation has no roots? So here, let's do, this would be, our axis of symmetry would be, for letter A, would be the x-axis, or the y-axis, and cross the y-axis at 2. So our vertex would be there. So if I put a 1 in for x, 1 squared is 1. 1 plus 2 is 3. So that would be here and here. So this one has no roots to it. Example 4, solve by graphing on a quadratic function in word problem format. So here's where we're going to use our graphing calculator to do that. As in 1941, the Boston Red Sox, Ted Williams, hit the highest pop fly ever recorded, assuming an initial velocity of 58 meters per second and an initial height of 1 meter. The function h equals -4.9 t squared plus 58t plus 1 models the height of the baseball h in meters after t seconds. So we're going to graph it on a calculator interpret the key features, and then find out approximately how long did the ball be in the air. So to do this, we're going to put it into our calculator. So you're going to go y equals negative 4.9 squared plus 58x plus 1. And then from there, we're going to change our Windows settings. And you can see the Windows settings that I have chosen here in this middle box. I chose a minimum of -5, and I only chose -5 just because I need to see a little bit below. So I just chose -5. The maximum, I have the x is 20, scale of 1. The y minimum, -5. I want to see a little bit below. And then the maximum 200, I just estimated 200. Somebody hitting a pop-up 200 feet up in the air is pretty high up. Y scale counting by 20. And then when you hit graph, you can see what the graph will look like here. So now let's go through the key features. So interpret the key features of the context of the situation. You can see our graph there with numbers on it. So the t is really your times, your x, and your h is the height, which would be your y. So the x-intercepts. The x-intercepts, it crosses at 0, 0, and it crosses at 12, 0. So what does that mean? It means that the height of the ball was 0 meters at 0 seconds and 12 seconds. So really, we're just going to worry about this one. So after 12 seconds, ball had a height of 0 meters. The y-intercept would be, and actually it's not 0, 0, it's a little bit above it. So this would be 0, 1, because if we look at our equation, our c was 1. This is saying the ball starts at a height, let me get rid of that x-intercept, at a height of, this would be 1 meter. Next, the symmetry. So to find the symmetry, you're going to find, so when you go to your graph, so let me get my calculator out to show you how to do that again. I'm going to go to y equals, the equation for this one, again, was -4.9 squared. The 4.9 x squared, and then we had plus 58x, so plus 58x plus 1. I'm going to change my settings windows again. So we had 0, I think we had 20 there. Count by ones. Y maximum was 200. Up here, I need to change that to -5. Minimum, I'm going to change that to -5 as well. Count by tens. Now, if we hit graph, now we need to find the vertex here. So we hit second, trace. Vertex is a maximum here, so number 4. Left bound, I need to go to the left of the vertex. Hit enter, go to the right of the vertex. Hit enter. Guess, hit enter a third time. And it says the maximum height, or the axis. So we would say 5.8, but if we round it to the nearest second, we would say 6. So we would say about x is about 6 seconds. So the vertex would be 6 seconds and 170, we'll just round it to 173 feet. So after 6 seconds, the max height was 173, not feet, but meters. Next, the domain. So the domain is our t, the time in seconds. So it has to be greater than or equal to 0, but less than or equal to 12. And then the range, lowest height would be 1. Actually, not 1, it would be 0, because I can't hit 0 here. And the highest point was 173. And it's increasing when x is less than 6, and it's decreasing when x is greater than 6. Positive, it's always positive. Negative, it's negative, negative, never negative. And then end behavior, as x increases and decreases, our y decreases. And then part C, approximately how long would the ball be in the air? So we found that the other 0 was here, so that would be roughly 12 seconds. Next question, disc golf. Rex is playing disc golf and is making a concentrated throw from a short distance known as a putt. The equation h equals negative 16t squared plus 15t plus 6 models the disc's height h in feet t seconds after the disc is released. We're going to graph the function on a calculator and then interpret the key features. So let's grab our calculator again. Go to the y equals. Going to change this to negative 16 x squared plus 15 plus 6. And I should be able to keep everything else the same, but maybe now change the window settings. The max height, we'll do 30. Then let's see, graph that. Let's make the x maximum, let's make that 10. Okay, so that's a little bit better. So there's our graph. Now let's interpret the key features. So here I have the graph for us. So again, our t is our x, our h is our y. So that x-intercept, where's across the x-axis? We go back to our calculator. Where's across the x-axis? So I go second, trace 0, number 2, hit enter. See, we need to go to the left bound. So here above, go below, enter, hit enter a second time, and we have 1.2. So we'll do 1.2 seconds. So 1.2 and 0. The other side is negative, so we're not going to worry about that. So it was in the air for about 1.2 seconds. The y-intercept, across the y-axis at, we go back to its 6. So the y-intercept would be 0, 6. Next, the symmetry. You need to look at the vertex here. So if we grab our calculator again, hit second, trace, it's a maximum, so number 4. Need to go to the left-hand side of it, hit enter, go to the right-hand side, hit enter a third time, and it says 0.46. So let's make that 0.5. When x is roughly 0.5. In our vertex, we would say 0.5 and 9.5. That means that after half a second, the maximum height was 9.5 feet in the air. Next, the domain. The domain, it can't have negative times, so it would be greater than or equal to 0. And this was 1.2. And then the range, the height, when lowest is 0, the highest was 9.5. Then increasing when x was less than 0.5, decreasing when x was greater than 0.5. Positive, always. Negative, never. Then behavior as x increases, decreases, or y decreases. And part C, approximately how long would the disk be in the air? So if we look at that, we found our 0 here, so that would be 1.2 seconds. Moving on to the last question we'll go through, the gangster thriller known as the roller coaster has a hill that follows the same path as the problem. The function h equals -16t squared plus 160t models the height h in feet of the cars above starting point of the hill after 3 seconds. We're going to graph the function and then interpret the key features. So grab our calculators again. Go to our y equals, and we have -16t squared plus 160x, and then we don't have anything else here. We graph what we have here. Can't see the whole thing, so we need to change the window setting. So we'll keep the maximum. Let's do the maximum, make that 20. Count by 1 still. The y minimum, keep that there. The maximum, let's make that 200. Still count by tens, then graph it. Still can't see the top part, so let's change the window settings. Let's make it be on the safe side. Let's do 500, and we'll count by 50s. There we go. And let's find our zeros, let's find our zeros. So number 2, hit enter. Below, hit enter again. So we have a 0 at 10. And then let's find the maximum. So second trace, we have a maximum, so number 4. Hit enter, go to the other side. Hit enter a third time. So our maximum will be 5 and 400. Now let's interpret the key features. Here's a graph which is similar to what we had. We did say that it was 405. We had our 0 at 10. Now let's identify intercepts. So our intercepts are 0, 0, and we have 10, 0. The vertex is 5 and 400. The domain, x such that x is greater than or equal to 0, but less than or equal to 10. The range, y such that y is greater than or equal to 0, but less than or equal to 400. It's increasing when x is less than 5. It's decreasing when x is greater than 5. And our last point, approximately how long does it take the roller coaster cars to return to the starting height of the hill? And it would be roughly 10 seconds. So that is our lesson on solving quadratic equations by graphing.